नमस्ते विद्याओं खुश रहिए आई JVWU Muskan Kumari from the Department of Science and Technology and I'm working here as an assistant professor in Vidyapeeth University and the Faculty of Education and Methodology. So we well known that your program is active semester and your course name is the Parallel Distributed Computing. In this course, I just want to discuss the session name. That session name is what your reduction paradigm and software taxonomy. Isn't it? So these both reduction in paradigm and software taxonomy, those are the different topics, but they are very little we can understand that much. So I will discuss these both topics in this one session. Isn't it clear? So I'm going to start these sessions, and before we start this session, I just want that you have to understand all this. So to share some own created word files, isn't it? So please hold for 1 minute. I'm just sharing that one file, reduction in file. Okay. So here this word files is I have shared with you, which I have to discuss during this session. So here, so session name is your reduction file. Okay. Now, what is the meaning of the reduction and what is the meaning of adding? You can think about this, right? So, reduction is basically to reduce something of that is in the real or the possible. So, paradigm or the distributed application. Now, paradigm means a pattern, isn't it? Pattern or the diagrams which we want to reduce in. So paradigm means a pattern, example, and model in the study of any subject. In the study of any subject of great complexity, suppose you are studying any subjects and that subject is have very complex, and it is useful to identify the basic pattern and the models. Then what you will try to identify the patterns and the models, and also classify the detail that according to the models, isn't it? So the paradigm will be represented in the order of the level of abstraction. The level of abstractions you just need to use all the things, isn't it? And which is shown in your figure. This figure is shown. The lowest level of abstraction is maxis passing. The lowest level of abstraction which is in a free form, that is the maxis passing, not the maxis you are passing for the others. So it is hidden from others, which encapsulates the least amount of details, and object space occupies the what do the object space? Object space occupies the highest level of abstraction among all the paradigms. Okay, so this diagram shows you that what? This shows you the object space, network space, object request broker, mobile agent, isn't it? And next one is the remote procedure RPI and RNI, isn't it? Remote method invocation, remote procedure call, client server, and all the messages passing. Okay, so this is from the high to the low. What level of abstractions is shown here? High to low. That object space is the higher level of the abstractions, and the network as a services object request and broker and mobile agent have the less level of abstraction than the object space, and the RPI and RNI is the lower level of abstractions than the network service object request broker and mobile agent. Now come to the next, to the client server has also the lower level of abstractions than the remote procedure call or remote method invocation. And the last one is the message passing, that is also the lower level of abstractions than the client server, and remote procedure call and RMI, network service object request होता है, mobile is an intent, mobile space, object space. Okay. So this diagram is basically showing you the paradigm and the level of the abstractions. Now come to the next point. What is the message passing paradigm? Message passing paradigm. A message is the most fundamental paradigm for distributed applications. In distributed applications, you will know that you have attached the multiple components and the computers in the one network area in the distributed form, and you are establish the communication between this all the proper channel of the computer which is situated in that network via through the message passing. Okay, so, message passing is the most fundamental paradigm for the distributed applications. A system sends a message representing a request. Now, here is the some parts of the your networking part, isn't it? A process sends a message representing the request. Suppose if you are taking the example of the client and server, the one side is the client, another side is the server, isn't it? And both are the like the nodes of the systems, and if suppose both have to communicate, must have to communicate, then how they will communicate? They will send the request and receive the request. Clear? So there is two-way communications in this network. Is two-way communications also. Suppose sender has sent a message to the receiver. So for that receivers, this message is act as a request. Clear? So the process sends a message that representing a request. The message is delivered to the receivers, which process the request and sends a message in response. This is the same things here that what whenever a process sends a message, that message pretends for the receivers as a request, and whenever the receiver sends a message to the sender, that message is pretend to the sender is like the response, isn't it? So this is basic the working architecture here for the client and server model. Okay, so now come to the next. In the turn, the reply may trigger for the request. In the turn, suppose if they are not sending anything, in turn the trigger for the request, which leads to the subsequently reply, and so forth. So far, the basic operations required to support the basic message passing paradigm. There are basic operations which is performed in this paradigm is the send, receive, isn't it? So there is only two operations which is performed here. One is the sending and another is the receiving. So for connection-oriented communication, the operation connect and disconnect are also required. During the connections-oriented communications, the operation can also connect and disconnect also required. Here you can see that the example of client server is like here is one process and this is the another process being okay, and here the message is passing. Process A is sending a bit of a sequence of the uh, sequence of the message which is acts as the request for process B, and process B is sending a set of the messages that is pretending for A as a response, isn't it? And this box is showing a message with the abstractions provided by this model. Here you can see that the abstractions is provided. No message is visible here. Isn't it? Abstractions is provided to the models. The interconnected process perform input and output by each other. Clear? So now in the manner similar to the file input output. The input output operation encapsulates the detail of network communication on the operating system level also. Clear? So now the client server paradigm. What is the client server paradigm? Perhaps the best known paradigm for the network applications, the client and server assign asymmetric roles to two collaborating the process. On one process, the server plays the role of server service provider and waits precisely for the arrival of the request. There is no need to hear for the request. The client issue a specific request to the server, waits for its responses, and in the other hand, the client or a specific client request to the server and waits for its own response. Simple inference. The client server model client server model provides a efficient instructions for the delivery of network services also. And it also operations required include for those server process to listen and to accept the request, isn't it? And for the client process to issue request and accept the responses also. So by assigning symmetric role to two sides, symmetric role to two sides. Symmetric role is what is the symmetric role here for the two sides? It means you can send and receive from the both sides, isn't it? Say a synchronous side. So asymmetric roles to the two sides. Event synchronization is simplified. The server process waits for request, and the client is turn wait for the response. Suppose client say sends the messages to the server side, then the server has to wait for the request till the client hasn't sent any messages to the server. And when the server gets that message, then clients has still to wait for the responses until unless the server didn't get in the responses. Clear? So many internet service are client server applications, and these services are often known by the protocols that are the application on which application will be implemented. Well-known internet service including like the HTTP and FTP, DNS, and finger etc. Gophers, etc. Okay, so this is all about the your paradigm uh, for which reduction paradigm you are reading, and this is the all about business. Please read these topics from your own also with say follow also the social standard book. Isn't it clear? So if you have any doubts in this session, then please comment in the comment section and please let me know that what you are facing problems in this session. Okay, so in the next session, I will discuss the next topic. Thank you very much.